Hi guys, this is Prateek. Welcome back. Welcome to Physics Simplified. Moving on in wave optics, we will cover optical instruments, and I have removed that thing, but I do remember. So we will start with optical instruments, and there are 3-4 things that we'll cover. The first and foremost is your eyes, which is the best optical instrument ever created. There's not by humans obviously, but by nature. And just understanding the basic principles of the eyes. So basically guys, we have got one lens through which light comes. It's a converging lens, convex lens. It is controlled by these two ciliary blue muscles. They're not actually blue in color. I just made them in blue. This is your eyeball, right? And here is an optical fiber, and here you will find rod and cones which detect the lights, which detects the colors as well. It is said that it is in the dogs, these rods and cones are not fully capable of detecting every color, but as human eye can detect all the 7 colors of rainbow. So we are lucky in that sense. Where we are not lucky is that over the period of time, as you age, these ciliary muscles become not in control so much, and you lose control. So this lens focus and defocus gets into trouble. So let me first explain to you how I work. You have to see at various distances, right? Suppose you want to see something at a very far distance. So the light is coming parallel, and it should converge on focus, right? And focus has to be here. Now to do that, these ciliary muscles they stretch the lens in such a way that it becomes flatter, okay, and the rays fall here. Now when the object, if you're looking at some nearby object, this lens gets flattened, so it becomes more like this when you are looking to a near object, and more like this when you are looking at a far object. Obviously this is an exaggeration, but yes, you understood, right? So there are two kind of problems which happen with your eyes. One is myopia, and other is hypermetropia, commonly, right? So myopia is when you can't see the things at a distance which are far away. I have got a myopia. So what is the basic reason for myopia? I would like to dwell upon it because I know it. That's why I have done a small research around that as well. So basically what happens is, in your childhood, when you start reading a lot of things, your tendency to make this lens into this small flat shape is higher. When you stop reading, when you start looking around, obviously right now your eyes are fine, this lens gets flattened up. But over a period of time, when you study too much, when you watch things very closely, this lens of yours gets stuck, and these ciliary muscles temporarily, note the word temporarily, are not able to stretch it to the position. Now when you go to a doctor, your doctor should recommend that at least for 25 days or 30 days you should do a practice, and you should try to somehow help these ciliary muscles, which can be done through focus and defocus. But then there's a huge industry, right? Ophthalmology is there. There's a huge industry where they have to sell you lens. They have to make you a customer throughout your life, like I am. So what they do is, instead they give you lens, and they ask you to wear spectacles. When you wear spectacles, your ciliary muscles, which were temporarily not able to stretch your lens, they get relaxed. That why ab kyun kaam karna hai? Why to work now, right? And in the process, if you have observed, in many kids, I have been a victim of that, and there have been many kids whose power of eyes, power is basically 1 upon focal length, right? So the power has increased over the age. It happens because you constantly, where you should be practicing focus and defocus and trying to make your ciliary muscles back into form, what exactly you are doing is you are substituting your eyes with a spectacle. It's like if my leg muscle has a tear, I would start using crutches and I start using walking them. So I would never be able to regain a muscle strength again if I don't exercise, if I don't try to recover. And in a similar fashion, our eyes don't get a chance, and we in this modern world, we all wear specs. I hate wearing specs, but yeah, I do sometimes. So you got the understanding, right, how eyes work. I've given you more than understanding. Second is microscope. So likewise here the lens was converging lens. It is called convex lens. Similarly, in a microscope, a convex lens is used, and if you see my ray optics videos, I have made convex lens as a real king. The real king means basically all the images all the objects, even the real objects and virtual objects makes real image. Only this game changer, the distance between focus and the pole. If the object lies in this distance, then the image is formed erect, right? And it is a virtual image formed behind. So I'll just tell you one small thing. In a mirror, you are expected to how do you define real and virtual image? So in a mirror, you want the image to get formed here itself, right? Because there's no space as such here, right? There's just a silver lining here, right? So this space is real. So if an image is getting formed here, it's a real image. While in the lens, you would want to form the image on the other side, because this is a transparent refractive medium. So in that case, this will be the area where real image is formed. So that's why in here, if the object is being there between focus and the pole, which is there in the microscope. If you take a microscope, I used to have a microscope. I don't have it right now. It isn't at my hometown. But if I had, I would have made you see it. So when you try to see it from a microscope, you obviously put the object very near to the lens, and you put your eyes as well to near to the lens, right? And in that fashion, you see an enlarged image of the object. So the microscope, this is a simple microscope, a very basic microscope, and till the magnification less than 9, it can be used easily. So now going into the mathematics, you understood, right? So if the object is placed here, the image will be formed like this, and it will be erected, and it will be away from the focus also. Our eyes are such that if an image is formed at a distance of 25 centimeter, then it is an awesome distance, right? So I would want to see an image which is 25 centimeter at a distance from my eyes. How much is 25 centimeter? I think this scale is 30 centimeters, so probably this range. So if this is my eyes, right? At this stage, as some object is kept, I would want to see it, and my eyes are very tuned to it. This is a scientific fact, a biological fact, which I don't have any explanation of, but yeah, that's a figure. Now, let me do some calculations here. So this is the formula for lens. 1 minus V minus 1 upon U is equals to 1 upon F. Focus is obviously positive because here the actual focus is there. Your magnification is V by U. I will try to eliminate U from here. So what I will write is V. 1 upon U is 1 upon V minus 1 upon F, which is, so U becomes VF upon F minus U. Are you with me, guys? I'll substitute here to VF F minus U. Now I'll cancel this V, and this becomes 1 minus U by F. 1 minus, this is V, sorry guys, 1 minus V by F. Now I told you that the distance V, I want it to be at 25 centimeter, and since the V is formed here itself in this microscope case, I would want the image to be at a distance of 25 centimeter from my eyes, and I'm assuming my eyes is very close to poles. So in lot of calculation that we do in microscope, we will do this kind of an approximation. So eyes are very close, so I'm considering this distance to be 25 centimeter, and since this is a negative, I have to write minus 25. So this becomes 1 plus d. I'm just putting the value of 25 centimeters d, desirable distance, upon f, and hence this is your magnification formula. Now, if generally a focal length of a microscope, if I take to be a 5 centimeter, this is my 25 centimeter distance. 25 by 5 is this d is positive, right? Huh? D is this distance now. This is not a minus or positive. This is always positive. So 25 by 5 is 5. 5 plus 1 is 6. So magnification of focal length of 5 centimeter comes around to be 6 centimeter, and that's how your microscope magnifies the object. I have told you few things, that convex, real king, if an object lies between this, erect image is formed. Only in this case a virtual image is formed. We put the object here itself and we try to see it from here. The desirable distance is 25 centimeter. I have calculated the magnification, which is V by U, eliminated U to find in V or F. I put the term V as minus D. I got the formula 1 plus D by F, which is majorly an approximation, and I got 6, not 6 centimeters, 6 as a magnification value. So with that note, let me check what's the duration right now. It's 11.33 minutes, so I'll end the video here. In the next video, we will talk about compound microscope, and I will write as well where are we, so that it gives us clarity. So with that note, bye bye.